Okay, so looking at our warm-up, measuring these angles here. All right, so for angle 1, so that angle right there, how big is that?
130.
Okay, so how big is that angle? All right, I'm just gonna do it like this. So it's obviously an obtuse angle, so it's not the small numbers, it's the big ones, somewhere between 120 and 130. It's somewhere right between 127 and 128.
That's more closer to the 28.
Yeah, I mean, right there it looks like it's exactly, but it's probably a little bit closer to 128. So I'm gonna go ahead and go with 128 on this. All right. Alrighty. Next, let's measure angle 2. This angle right here. Okay, how big is that? There we go. Sorry, mine wasn't lined up. It's still not. That right there. So where is it? Yeah, it's right. It's again, it's kind of split in between there, but it's pretty close to 73. Okay, I'm gonna go with 73. Okay, next let's measure angle 3. Angle right here. Yep, there's between 50 and 60, about 53 degrees. Okay, and this last one, number 4 here. That one. What is it?
106.
About 106. Okay. So about 106 degrees. Thank you, ma'am. All right. So now what I want you to do in your calculator,
Add them up.
add those 4 numbers up. See what you get.
Not easy. Yes. Yes. What?
We were spot on with the calculation.
360. Did that 360 happen by chance?
Yes. No.
No. No. It'll always add it up to 360. Did not happen by chance, okay? So in a circle, those central angles will always add up to 360 degrees. Just a constant fact, okay? So I'm not going to do this one right here just for time's sake, but on this one, if you were to measure angle 1, how big is angle 1? Okay. So yes, it is exactly 180 degrees. How big is angle 2? 180. And when you add 180 and 180, what do you get?
360.
You get 360. Yes. Okay.
I'm saying.
Okay. All right. A central angle of a circle is an angle with the vertex in the center of the circle. All right, a central angle of a circle is one that's in the center of a circle, which makes sense. So this angle right here, that angle right there is what we call a central angle. Okay, that is a central angle. It's in the center of the circle. And the reason we're making that distinction is next week we'll talk about inscribed angles, which are not in the center. They'll be like on the edge of the circle like this. And then even after that, we'll talk about angles that are neither one of those. Okay, so everything we're going to be dealing with today and for Monday, Tuesday, and Wednesday of next week are going to be central angles. Okay, so right here, based off what we just said, all right, I don't know how big angle 1, 2, and 3 are individually, but if I add angle 1, 2, and 3 up, what do they add up to? They're going to add up to 360 degrees. Okay? I know they're going to add up to 360. Okay, so on this one right here, this angle is 108, this angle is 22, this angle is 90, and I'm looking for this angle right here.
You're gonna add those, subtract it from 360.
Okay, good. So that's one way, and that's exactly right. The way I like to do it is just start off with the total number 360, take off 108, take off 22, take off 90, and whatever's left has to be the measurement of that angle. So 360, take away 108, take away 22, take away 90, what's left?
140.
Is 140 degrees. That angle is 140. Okay? Then if you wanted to check, you could just go back in and add 140, 108, 22, and 90. Make sure that adds up to 360. Okay. Here, same thing. I'm looking for this angle. What is it? It's 140, right? So if you take 360, take away the 180, take away the 40, that leaves 140. All right. An arc is a portion of a circle defined by two endpoints. A central angle separates the circle into two arcs with measures related to the measure of the central angle. Okay, so the arc is related to the central angle. We'll talk about that in a second. All right, so what an arc is like starting at some endpoint right there and going around to right here. This is what we call an arc. It's basically a piece of the circumference. An arc is a piece of the circumference. Okay, so as we look at these two below here, so if you'll notice where I've got shaded, it's like kind of bold here, and then here it's like shaded right here. So both of these are arcs. What differences do you notice between these two arcs right here?
One's at the top and one's at the bottom.
One's at the top, one's at the bottom. What else do you notice is a difference?
One's greater than the other.
Yeah, one's bigger than the other? Yep. Okay, so that's basically going to get to the heart of what we're talking about here. So on this one up here, this is what we call a minor arc. Call that a minor arc. Now, a minor arc is the shortest distance between the 2 points. Okay? It's the shortest distance. What I mean by that is this, is if you take this point and this point, going from here to here is the shorter way to go. You could go here, which is the longer way, but on the minor arc, you always go the shortest path from one point to the end point, other point. Okay? And on the minor arc, it's going to be less than 180 degrees. Okay? It's going to be less than 180 degrees. Okay, so we call this one the minor arc. What do you think this is called?
Major arc.
Major arc, good. Okay, it's the major arc. Now if we fall into the same pattern as the other two descriptions up there, what do you think we're going to say about this? It's the
more than one.
longest distance between the two endpoints. And what's the other thing? It's going to be more than 180. So on this one we had less than 180. On this one we have more than 180. There's only one other consideration. What's it going to be?
180.
When it's exactly 180, right? This right here. So this we just call a semicircle. Now in a semicircle there's not going to be a shorter or longer distance because it's going to be the same distance either way. So there's nothing to say there. But what you said is that it is exactly 180 degrees.
Where does the end?
Good question.
They could just subscribe to just do movies.
There you go.
Good answer, good answer.
Alrighty, so let's flip it over and let's think about that. Guys having some problems up there?
Get in trouble with me.
Okay,
In the corner.
so what we're going to do is, number one, we're going to say if it's a major arc, minor arc, or semicircle, then we're going to find its degree measurements. Okay, so on the first one, so it's talking about arc GH. Now, whenever it talks about an arc like this, unless it designates, you're always going to go the shortest distance, okay? So arc GH is from here around to here. So first of all, is that a major or minor arc?
Minor.
It's a minor arc, that's right. Now the other thing we haven't talked about really, except for just a second ago, is that to find the degree measurement of an arc, it is the same degree measurement as the central angle that forms it. So on this one, this is the central angle that forms arc GH. So how many degrees is that angle? 122. And since that's its central angle, that's how many degrees that arc is. So the arc is 122 degrees. Now we're talking about its degree measurement in this part. All right, next is arc GLH. Now, the order of the letters matters here. You've got to go from G to L first before you hit H. Okay, so it's going to be starting at G, and if I go this way, I'm going to hit H before I hit L, so I've got to go the other way. So I've got to go from G to L first. So I hit G to L, then just keep going all the way around until I get to H right there.
I would lean towards it.
So is that major or minor?
Major.
It's major. Okay. Now, let's find the degree measurement of this arc. Okay, so if I were to go all the way around, if I were to start at G and go all the way back around to G, how many degrees would that be?
360.
It would be 360. If I started at G, go all the way back to G, it would be 360. Well, if you notice what's going on here from G all the way to H this direction is the whole circle excluding this 122 degree piece.
No.
Yeah, so I'm just going to take 360, the total, and take off that 122,
238.
and that tells me that that arc has to be 238 degrees. Okay. All right, the next one is GLJ. So GLJ.
180.
Okay, good. It's semi, and it's 180 degrees. Okay, what I want you to do now is those next three. Do that 2A, 2B, and 2C. Tell me if it's major, minor, or semicircle, then find its measure. Okay, so one thing to notice here is it says that PM is a diameter. Okay? So since PM is a diameter, you know that's exactly half of the circle right there. That makes half the circle for a semicircle. Okay, so that first one asks about MQ. So M to Q, is that major, minor, or semi?
Minor.
It's minor. Okay? All right. Now, you know that from here to here is half a circle, that's 180. So how are we going to find the measurement of this right here?
180 minus 50.
180 minus 115, and whatever's left is the measurement of our arc there, which is what?
65.
Okay, good. So that's 65 degrees. All right, next one is MNP. So MNP, what's that?
180.
It's a semi, it's 180. Okay, then MNQ, so that's here all the way around to there. Got to keep going around the outside. A lot of times what people want to do is they get to M to N, or from M to N like this, and it's like it's so far around there, then they try to do something like this to get to it. No, you just keep going around. Okay, go all the way. So is that major or minor?
Major.
Obviously it's major. And we found that this piece right here is 65. So it's the whole circle less that 65, so that's right, it's 295 degrees. Okay, so everything we're talking about right here is the degree measurement of that arc. The last thing I want to talk about for a second here is something that we actually talked about the other day. This is asking about the length of the arc, okay? So notice the difference. Up here, it's talking about when it says find its measure, it's talking about finding its degree measurement. Down here, we're finding the length. So literally, how long is it? Okay, and like I said, we did this the other day. So the formula on this is 2 pi r times m over 360, which is the same thing as what this says. I just like it written like this better. 2 pi r times m over 360. Okay, so what we're doing is we're looking for the length of zy. Now first, what would the degree measurement of zy be? It would be 75 degrees, okay? And that's good. But what I want to know is how long it is. So I'm going to plug into this formula. 2 pi times what's the radius for this circle?
75.
4?
Oh,
The radius is 4, right?
I was going to say that.
Then what's the measurement of the angle that makes that arc? Or how big is the arc? It's 75, right? Over 360. Bless you.
Thank. 5 point.
42 or something?
Yes, sir.
5.42 inches.
I thought it was
5.24.
5.2. Yeah.
I got 5.34.
Yeah, that's what I got.
Wait, 2.4?
Yes.
Oh, okay, yeah, I got it backwards, sorry. Okay, so I mean, there's nothing to it. It's just plugging into the formula. So on this one, 2 pi times, what's the radius on this one? 5, which you could have just, done 10 pi. Same thing. And we're looking for zy right here, the length. So 130 degrees over 360.
And it's like any given degree.
Yeah, it's the degree of the angle of the central angle
Alright.
that makes that arc.
Could you do 50 on that X?
Okay, this would be 50, but the 50 would be, you would use the 50 to find the length of this arc from here to here. This over here says find the length of zy.
Oh, okay.
And so zy is right here, and it's made by that 130 degree. So what does that give you?
11.34.
11.34 centimeters.